Good evening. I hope you guys are having a great day today. Today we're going to be talking about dividing rational numbers. The rules for dividing rational numbers are the same as the rules for multiplying rational numbers. If we have different signs, our answer is negative. If we have the same signs, our answer is positive. And of course, this means if we are multiplying two rational numbers, so two positive rational numbers are going to yield a positive answer. And if we're dividing a positive and a negative, we're going to get a negative. It's only with two, okay? Same as with multiplying. So what I want you to do is I want you to place each quotient and its value on the number line, or leave it behind if it's an undefined expression. What is an undefined expression? Remember, undefined means the denominator equals 0. And in math, that is a huge no-no. Okay, so take a minute, put these on the number line, and we'll meet back. Okay, how did you do? I'm sure that you were successful on this one. I have them all lined up in numerical order. Okay, let's move on. You can rewrite any negative number as the product of -1 and a positive number. This allows you to rewrite any rational number as the quotient of two integers. This is one of the most useful things I have used in my math career. Okay? You will carry this along with you through pre-calculus and algebra 2 and calculus and all the good math classes you'll take above and beyond when you get out into the collegiate world. So if I have -3/4, really it's -1 times 3/4. Okay, which is really -1/1 times 3/4. So it's really -3/4. Or, if we look the second way here, I can have it, and if I go through and look at the steps, I can see I have 3/4. So it doesn't matter where I put the negative. I can put it completely in the front, I can put it in the numerator, or I can put it in the denominator. Okay, it's got to be in one of those three spots. And here is the rule for it. So let's move on to our next page. Here are some examples. Take a minute to do these, and we'll meet back. There they are. How'd you do? I'm hoping you didn't use a calculator, because we're not supposed to be using one. Okay. So now if we move on, two numbers whose products are 1 two numbers whose product is 1 are reciprocals. So I have 1/2 times 2. When I multiply those, I get 1. -2/3 times -3/2 gives me 1. So reciprocal, P over Q, its reciprocal is Q over P. And if I have -P over Q, its reciprocal is -Q over P. So look at this up here. If I have -2/3, its reciprocal, I could rewrite it as -3/2. Because when I multiply them, I still get a +1. This goes back to that placement of where to put the negatives from the previous slide. Okay? Personally, I like to keep the negative up in the numerator. Okay? And you will see that as you progress through these. So cross out each choice that is not the reciprocal of the number. So this is negative for the first example, so its reciprocal has to be negative. The only choice is the third choice, and it has to switch. The numerator and denominator have to switch. For the second one, it's the middle one, so I'm crossing out the first and last. For the third one, 1/8, the reciprocal is 8. For the next one, -6, our reciprocal is -1/6. And for the last one, I have a mixed number, so the first thing I have to do is I have to convert it. 3 times 1 is 3, plus 2 is 5, 5/3. So its reciprocal would be -3/5. Okay. Does 0 have a reciprocal? Nope, it does not have a reciprocal. Since 0 equals 0/1, technically 0 any number but 0, the reciprocal of 0 would be 1/0. However, we cannot divide by 0. So 0 does not have a reciprocal. Also, the product of a number and its reciprocal must be 1. But the product of 0 in any number is 0. So this fails on 2 concepts. You can't divide by 0, and the product and its reciprocal, the product of the number and its reciprocal is not 1. Dividing a number by 3 and multiplying by 1/3 gives the same result. The same is true if 3 and 1/3 are negative. So if I do 15 divided by 3, I get 5. It's also the same as 15 times 1/3, because here I can make that 15 over 1, and 15 times 1 is 15, over 1 times 3 is 3, which would still take me to 5. Lots of rules here that you guys already know. So, to divide by a fraction, we multiply by its reciprocal. Now, when we did subtracting integers, I always did stop, add the opposite. Some people do the keep, change, flip. That's one of the ways I've heard of. I keep the first number, I change division to multiplication, and then I flip 3/4 and make it 4/3. So the first fraction stays the same, that's my keep. The operation changes to multiplication, there's my change, and the flip. The second fraction becomes the reciprocal. So now here we're circling the equivalent multiplication expression for each division. So here, -1/9 times 18 over 7, so that is the first one. All right, do the next 3 and we will come back. There you have it. How'd you do? Okay, here are some examples. There are 4 of them. I would like you to do these examples, and we will go over these in class tomorrow. So this is one of the things I want you to do so that we have it ready for tomorrow. And here's the remainder of these 2 problems. All right, so let's move on to example 4. On a research expedition, 3 oceanographers in a small submarine descend 4/5 miles per hour. The equation D equals -4/5 t gives the depth D in miles of a submarine at t hours. How long does it take for the submarine to reach 2 2/3 miles below sea level? So this D equals -4/5 t. We did this in the beginning of the year. Distance equals rate times time. So my distance is 2 2/3. -4/5 t. So we have to divide both sides by -4/5 to get t by itself. When I do that, I'm going to come to here. Remember, I can't have a mixed number, so 2 2/3 becomes 8/3. Divided by -4/5. And that's going to equal t. So 4 goes into 8 twice, and I get -10/3. So I get -3 1/3 per time. I need to make a correction as I look. My depth is negative. Sorry about that, I had to stop and think about that. My depth is negative. And how did I know that? Because when I went to do my problem, I ended up with a negative time. And I can't have time be negative. So my time is 3 1/3 hour, or 3 hours, 20 minutes. Sorry about that. So let's look at our next problem. Snow is falling at a rate of 3/4 of an inch every hour. How long will it take for there to be 3 inches on the ground? So we have 3/4 of an inch every hour, and we end up with 3 inches. I have to divide both sides by 3/4. So I get t equals 3 3 divided by 3/4. So T equals 3 times 4/3. So T equals, it's going to take 4 hours. That's a lot of snow. 3 inches in 4 hours, that's pretty quick. And I want you to do the last example as one we will go over for homework. Do it, and we'll go over it in class tomorrow. Have a good night. Bye-bye.